Hello everyone, welcome back to this Beckhoff TwinCAT3 motion control series video. In this video, we will finish programming this offline basic motion control commands. They include MC reset, MC power, MC home, and MC jog. And we will declare the variable at first, and then we will connect all those variables to those instructions. In the previous video, we call those function blocks. So we will continue. So firstly, we will declare the variables. To declare the variables, I would use this global variable list. Let's go to this GVL here, right click, add global variable list. So I can name it GVL underscore as a single access. So firstly, let's declare one variable that is the access date type. Okay. So this access, we name it single access, and this is that date type, okay? And then let's declare the instant DB. So at here, I will declare those 4 instant DB here. And their prefix is named FB, so we know this is the one instant DB. Instant DB for reset, power, home, and jog, okay? And date type, they are this. And then let's declare some common used command. Okay, I declare the common used command for the reset. So we have a reset execute. For the power, we have a power enable and enable the positive and enable the negative. And for the home, we have the home execute this command and the home sensor input. From Beckhoff motion control area, the home sensor is named cam input. And for the jog, we have a jog forward and a jog reverse. They are bool command. And then some function block, we can set some variables, for example, the override percent value or the home position that set position value. Those values are long real date type, so we can declare some variables right here. So we could name them as a variable or parameters. For example, the power override, home position actual value, set position value, and the jog velocity. Okay, and other than this, if you recall, we do need some variable that can receive each function block status. As we can see, the busy, active, status, arrow, ID, done. Those signals are very common used for each function block. So we can set up one structure. We can declare that structure at this DTU. So every tag can use the same structure that can help us to very quick to declare those variables. Okay. So we can go to the DTU, add this DTU. So we can name it as a MC underscore status DTU, open. Within this structure here, we can declare, for example, the done, busy, arrow, active. And keep in mind, this arrow ID, that is the udent, this date type. After we declare this structure here, so we can declare the variable based on this structure. Okay, go to the GVL underscore SA here. We can name it status, this area. So for the reset, for example, we can name it ST, SA underscore reset. And this time, the date type we will use, so it named MC underscore. This structure, I rename it as a ST underscore MC underscore status. Okay, let's go back to this GVL underscore SA. So this time, this date type here, we will based on this ST underscore MC underscore status. So following this way, we'll declare others. At here, we declare this main access date type and this 4 instant DB here and the input command, variable and the parameters and the status. So after this, we can build the project. After we build, those variables will be declared and will be registered in the system. Okay, and then let's go back to the program. Firstly, at this MC underscore reset, so we can use that function block instant DB we declared. So that is a GVL underscore SA dot. So here, IB reset. Okay, for this power, okay, power. For the MC home, dot home for the MC jog, GVL underscore SA dot SA jog. Okay, single access jog. So this access here will tell this function blocks to know which access those function blocks are controlling. For example, here. So this access here, we will use this single access because this single access, this name is based on this data type, access underscore ref. So at here, that variable under the GVL underscore SA dot. So single access here. Okay. So we are using this for those function block because they all controlling this one access, this virtual access. So they will use the same, this variable tag name. And then we will connect this variable name to this access configuration here. So firstly, we will paste here. So copy, paste here, paste here. So with this connection, those function block will control this logic access. And how our motion system, this access node, those function block controlling this guy. So we will go to here, double click. Here, we will click this link to PLC and we will connect that variable. Because we haven't finished the program yet, so the system will show a lot of errors. This variable haven't successfully compiled and built up. So we will temporarily leave this here. Let's go back to the program. Let's go to the MC reset. Let's connect all those variables. Okay. And if we recall here, so this MC reset, this execute, we will use this BSA underscore reset execute. And for this output, we will use this ST SA underscore reset. We will use this structure. Okay, let's go to connect them. And this done signal, we can right click, click this insert coil. Okay, and this variable GVL SA dot. So we will select the SDSA underscore reset. Click dot. So here, that's the done signal. We will select the done signal. Okay, and others. Okay, we connect all the tags at this function block MC underscore reset. Next one, MC power. So MC power, the key three important input, they are enable positive, and enable negative. If we recall, those three enable and this override command, actually the same idea as when we go online and we enable this area, controller enable forward and backward, and the override speed. Okay, they are the same idea. So here we will use this power enable positive and enable negative. And this override setting, we will use this. So long rail power override, that is the long rail command. Okay. Enable positive, enable negative, and override. And this power override. That power override is a 0 to 100, that is 1% value. This power override, that's value from 0 to 100, especially for the first time or first couple cycles for testing purpose, we will set a lower override, for example, 20 or 30%. That will allow your system run very slow speed, so running as a safe speed. This long rail, this unit is a percent, and value will be 0 to 100. And regarding the buffer mode and these options, we can go online to search the help of this MC underscore power. If you install that 2 GB package InfoSys system, that allows you to search any help from the offline. This is the online InfoSys. For example, we can go to search the Beckhoff InfoSys system, and under this PLC library, TC2 underscore MC2, and this access functions MC underscore power, here it explains the buffer mode and options here. To check out this buffer mode detail, you can search this online. Okay, and for example, this MC underscore buffer mode, if I click this link, and we will see this MC underscore buffer mode, it defined those type. The typical two mode we could select, one is the buffered, one is this blending low or the previous. So those two modes are common used two mode. For example, if the first command haven't finished yet, and then you trigger the second motion command, how this second motion command take over this speed. Sometimes if you just take over the speed using the previous one's speed, we could select those two modes. Or sometimes we must finish the first command and then start the next one. So we will use this default buffered. If we type in nothing here, default, that is the MC_buffer mode. Okay. Go back here. If we leave this here as a default, so we can delete this. Just leave as this. And it will use the default MC buffer mode. Also, we can paste the couple mode prepared at here. And by default here, it doesn't show any comment here. We need to enable that comments. So we need to go to the tools, go to options, find out the TwinCAT, find out the PLC environment, and find out this FD ladder logic editor. And at here, we will click this show network comment, or you can also enable this network title. Okay, click OK. After we enable here, so once you leave this cursor at here, you will see this green line here. That means we can type in something here. Okay, so we can paste that mode, leave at here just for prepare. Okay, and this option we can also leave as a default. Okay, check out the detail. You can go online, search MC_power from Beckhoff Infosys system, and the same idea. We will connect the variable at here. Okay, we connect all those status variable at here. Okay, this is MC power. Let's go down. And this is MC home. Home is a complicated usually. Basically, we have an active home and a passive home. The passive home, that means we will use our logic, and once we trigger this execute, we will write that position setting into our access, directly set our encoder this access value. Another way that is active. Active means the system will run one sequence internally. So for example, once we trigger the active go home, so the access will go back to search the home sensor. And once it searches the home sensor, and then it will stop itself and go back. In some cases, other than using the home sensor, we could also use the zero mark from the encoder, probably use the zero mark from the sensor and set the actual position. That will be very accurate. To use the passive home or active home totally depends on your application. For example, in my project, most of the cases actually I will use the passive home. That because for the positioning control, usually we will travel our palette or travel our mechanical things line up with the tooling. And actually at that tooling position, we will define as a 0, or we will define a certain value, for example, 600 millimeter position. That position, we will directly set that position. Once this tooling lineup position is accurate, actually we do not need to care where is the actual 0 or where this palette will be stopped. So that working position is a position we really care. So usually we will use this execute and set directly the position value to the access. We will set that homing mode to a directly mode. Basically means the passive mode. We trigger and set the value. But for some packaging machine, so if the packaging machine especially use the incremental encoder, probably we will use the active home, allow the access go to search the home itself. Okay, to find out the detail of this MC home, we can go to the online and search this Beckhoff Infosys and find out this homing, this description. So under this TC2_MC, and let's click this homing, MC_home. Here, this buffer mode and the homing mode. So we need to read the detail. For example, this is the active go home procedure. Okay, and keep in mind, that homing sensor in Beckhoff, they called calibration cam, that sensor. Okay, to better understand, we can copy this and paste into our ladder logic. So for example, we can paste this description here. The passive mode I introduced, that is this MC_direct, that will set the access position directly to the position without executing a movement. So that means we can use the jog mode, line up the tool first, and then execute this command. And that time, it will directly write one value into our access. This is the tooling lineup. Okay, then we will connect the variable at here. Okay, this is the home execute. And this is the home sensor. But if we use the passive, this MC_direct, we won't use this. It's just for a space holder here. So this position, I will select that home position. This is the long rail variable home position. Okay, and this is a homing mode, so we can type in this MC_direct. Okay, and this buffer mode and options we can leave as a default. And the same idea, we will type in the variables at this output status. Okay, we connect all those variables. I will select this MC_direct. Directly write this home positioning setting into the access. Okay, so MC jog. And here, let's connect this jog forward and jog backward command. And regarding those mode, position, velocity, so we can search the MC_jog online help. Let's search this manual motion under this MC_MC2, MC_jog. We'll see the position, velocity, acceleration, deceleration, jerk setting here. And keep in mind here, this velocity, acceleration, and deceleration, as we can see, if we leave the 0 value at here, so the system will automatically select the system manager setting into our access configuration. We could leave as a 0, and we can set that value at this access configuration. Okay. We could leave the acceleration and the deceleration as a 0, and the jerk as a 0. And the velocity, here, this velocity, we can control this velocity. For example, from the HMI, we can set this value very low speed. Once we press the jog forward or the jog reverse, we can slow jog the axis. So this velocity, we can control that. So here, we can connect. This is the long rail jog velocity value. Okay? And this position, we can also leave as a 0. Mode, we can also leave as a 0. Okay. Regarding those acceleration, deceleration, and jerk, if we leave a 0 at here, that value will be automatically follow the setting in the axis configuration. And we will see this default dynamics, acceleration, deceleration, and jerk. The system will use those settings here. Okay. And then same thing, we will connect the variables for those output. Okay, we connect all those variables for those output status. Okay, basically we finish those typical setting and the variable connection here. And here we can compile, build a project. Okay, now is no error here. And after we build the project to allow this logic, this access connect to our access setting here. So we need to go to this access, go to setting here. This link to PLC. Once we click this PLC here, once it's compiled successfully, we will see this single access, this variable name that based on the access ref, that date type. Once we click OK, that means using this variable, single access this variable, it will connect this access setting with our logic program. So this single access, this variable will run it as a bridge, connect this function block with this access, this is setting configuration here. Here we finish those full typical function block for this access control. And if we record this program structure, from this main, we call this motion control, this program. And from this motion control, we need to call this method because all those programmed within this single axis underscore LD, this method here. From this motion control program, we need to call this method. So add here, single axis underscore LD. Okay, this program will call that. All right, so let's build a solution. All right, let's temporarily park here. In this video, I mainly introduced how we can connect the variable and program the motion control command MC reset, MC home, MC jog, and MC power on. So in next video, I will show how can we download the program using my laptop and how can we do the online test for those 4 instructions. All right, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.